Good day to all Honorable 12th ISIEM Conference Committee. In the afternoon, I would like to explain briefly my research with title Management of Plastic Waste Recycling by Value Stream Mapping. There are presentation outline, introduction, methods, result and discussion, and conclusions. So as we know, plastic is one of the most massive raw material production. It's a raw material that is relatively cheap, durable, and versatile. Plastic product has been beneficial for the society in economics, occupational, and other activities related to quality of life. On the other hand, plastic can impact negatively, such as ecological damage. From this picture, we know that Indonesia is the second total plastic waste in several countries and estimate up to 2025. So we have to concern about our country, especially in waste plastic recycling. There are several ways to decrease the amount of plastic garbage in Indonesia. One of them is recycled plastic in other products or materials. For category of plastic recycling includes recycling output, known as virgin material or product raw materials product. 2. Recycling output has no similar characteristic in with the original product. 3. Recycling product is the form or fuel or chemical such as plastic scrap which become urban waste. And recycling output is in the form of energy, not materials. There are various tools and techniques to implement Lean principle to industry. Among the various tools of Lean, and we choose value stream mapping and the important tools in Lean manufacturing to use for the industry. There are some previous research in value stream mapping we can see in this list. And the methodology, we have 5 steps for the methodology. First, we have conduct community study regarding plastic factories existing in Indonesia. Then we visiting the factories and we analyze this research. Step 2, we categorize raw material and process of plastic waste processing mechanically. And step 3, identify the existing waste processing that existing today and explain more detail regarding physically and non-physically resource management. Step 4, conduct the value stream mapping. We have some page, creating big picture mapping, counting activities time, making the spreading questionnaire, conducting facade analysis faithful in accordance to the 8 waste rule in lean manufacturing. And the last step is step 5 is to analyze the best practice and give it recommendation for plastic waste processing management according to the analysis data step 3 and step 4. So research location for the example of reprocessing plastic waste into pellet can be seen in ongoing process in MBG, the one small medium industry plastic waste in Bekasi, and the second were pellet AGB factory in the Surakarta. They produce pellet until fuel. This is the category of material produced. First cycle, second recycle, and third recycle, and fourth recycle. We can see from the presentation. Result and discussions. We have explanation both category 1 and category 3. Category 1 is for MBG and category 3 for AGP, sorry. And for the category 1s, the MBG, we have the raw material from the polyethylene and polypropylene, the identification, separation, and sorting plastic, and then they press the plastic, and then the second process they're going to grinding, and then the step they have cleansing, and then they drying the plastic, then the process making broom from the used oil plastic. It is same with the AGB. first they sorting, washing, grinding, and then the drying, and the step 5 they put into the silos. Then they step 6 agglutination, step 7 extrusion, step 8 granulations into the pellet. This is the identification, separation, and sorting plastic raw material, category 1 and category 3. I don't want to explain, but we can read from the presentations, the explanation for category 1 and category 3. Next, we are going to identification of a plastic category in factory, category 1, by using from the mechanical, waste management, and cause of degradation. Output recycled plastic pellet. This is the mechanical for the MBG, and this is the value stream mapping facet that we know from the list. The value edit time 4908 and non-value time 180 and lead time 5088 minutes. So the non-value added and value added for process factory category 1s, they have some improvement in transportations, chopping, cleansing, drying, packing, and lead time. There are 84.8 minutes, and this is the picture for the value stream mapping category 1 thermoplastic recycling system. From the questionnaire, we find that total score value, they have 14 for the category 1. This is the comparison between few of the researchers and the owner. This is difference. The owner said the unnecessary motion, but from the research, we talk about the weighting, and the owner said the unnecessary inventory. And the research passes to excessive transportation, and the same with the owner as well. Facet decomposition in MBG, we know the total is 100%. The top one, the process activity mapping, and then a supply chain response, and a product variety, quality filter, demand application mapping, decision point, and physical structure. The next, this is for the category 3, there is a value stream mapping. We see from the picture that the concern is about the weighting and unnecessary motion and defect. So the owner said the unnecessary motion for weighting and defect, but for the researcher we talk about weighting and excessive transportation. And the recapitulation, we know that the activity process number 1, supply chain response matrix number 2, and so on. And this ranking, we know for the factory 3, we can identify the value stream mapping. The conclusions is the big mapping of plastic waste process flow category 1. The main waste, what happened in managing plastic pellet are motion and weighting. And in transportation cannot be declared review because the what is priorities for raw material, handling and grinding process is conducted in series. Improvement recommendation is waste that happen in the production process of plastic pellet are to add new tools, whether for cleanser or dryer, and to improve machine improve, so they follow the gravity direction. And for the category 3, the waste happens in the unnecessary motion, weighting, excessive composition, and defect. So improvement can be done by putting raw materials in the accordance to the capacity of machine periodically, so that there are no delay in waste management process that is linear to the management cost improve. And improvement of the management factory is need to layout for the raw material access. It's supposed to save space, cost, energy, and increase the revenue of plastic waste entrepreneur. Thank you, and thank you for the Trisakti University who has the institution that sponsor me in this conference. Thank you so much.